fact, for all of these lot, with the exception of DDL, you never see the text of the SQL that was executed. For example, you never see insert into sysauth dollar, whatever kind of thing. You never see that. But what you can do is break it down by looking at the opcode to see there was an insert, checking what object ID the insert was performed upon, looking at what rows were inserted, and so on, which we'll obviously look at in a second. But 24.1 DDL indicates a data definition language operation, and the text of that is now stored in the redo log itself. So, for example, if someone goes and creates a user account for themselves, that text will be there. If someone creates a table or a function, that text will be there. Certain alter statements will be there as well, and obviously drop and so on. Now, this is a section of the redo log, and you can see up here this is an insert example basically here. Right there is the opcode for insert. So we know that we're looking at an insert here. On the left here is the timestamp. Now, obviously, when you're doing a forensic analysis, time is important. Now, the question is the time related to when the insert actually took place or when the record was written to the redo log? It's actually when the record was written to the redo log. So if the system hasn't flushed changes to the system or written it out to the redo log, there might be a considerable lag between an actual insert taking place by an attacker and it being written to the redo log. Now, as long as you can account for that time difference, then it's fine. Now, here we can see the user ID down the bottom there of the person who did the insert, which then we can refer back to the user table and work out, what their name was. And we can see the data that was inserted. So we see C102, which means the first row is value 1, then C105, which means the next row is 4, and then C2, so that's 800 and something or other. Now, when we look at the object ID, which is there, we, having dumped the data dictionary, know that the object ID the name of the object that correlates to that object ID is sysauth dollar. So one has to question here, who the hell is inserting into sysauth? Sysauth dollar keeps track of role privileges and so on. So if you're a DBA, there'll be a row entry in there for you. Now, given that we know what sysauth the columns are, what's happened here is someone has done a direct insert into the sysauth table to give the public user / role, whatever you want to call it, DBA privileges. So that is not normally what would happen. If you're granting privileges, there would be a DDL entry. There should never ever be a direct insert into this table. If we actually dump this number here, what we actually find is that it's one more than the previous. It's like a unique constraint. I can't remember off the top of my head what it is, but suffice it to say that it's one more. So probably what the attacker's done, and without direct evidence of this, is a purely supposition, of course, is that they've just selected like max and added 1 to it. So this, by dumping this insert from the redo log, we can see that something nefarious is going on. So we already mentioned the timestamp is when the redo entry was written. It's not when the action was taken. How is time recorded in the redo log? Well, it's basically the number of seconds from midnight, 1st of January, 1988. Don't know what's special about that date, but what's interesting is if you set your computer clock to a date before that, Oracle 10G will stop working. So here's a nice DDL example. We can see, and again, this should immediately raise our heckles on our neck, because we see that the user Scott here has executed create user wiggy 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 identified by values, whatever the password is, kind of thing. Now, this here is the schema in which the action took place. This there is the executing user. Now, oh sorry, that 1801 there, 18 in is the hex for 24. So that's the opcode for the change vector for a DDL operation. But the important point here is Scott is the executing user, but the current schema is sys. So that probably indicates that he has created this user via a SQL injection floor, PL SQL injection floor. Again, I say probably because without actually seeing the actual injection floor going across the wire or in a log somewhere, we just have to make an assumption. But suffice it to say, we know that Scott was the guy who did this. Now, how are we doing for time? What about evidence of selects? There are no objects created during a select. There are no transactions that occur during a select. And for those Oracle people out there who go, yeah, what about a select for update? Well, yeah, okay, accept that one. But when someone's stealing data, they're not going to be doing a select for update. It's just going to be like, for example, let's say they're coming in via a web application and they inject a UTL HTTP.request, come back out of your network, post to me via a web server, using UTL HTTP request, the data I want to select. Well, there is no object created in that time, or there's no transaction or whatever. Simply there's stuff posted out. Or if it's not a blind SQL injection scenario, it's just dump the data back via a union select into the web browser. So, having looked around and poked the system, there are actually evidence. There are places where evidence of just plain old selects can be found. These include the automatic workload repository, the cost-based optimizer, and of course the fixed view VSQL. So, what is the cost-based optimizer? Whenever anybody executes a query in Oracle, that obviously has to be compiled into a query tree, an execution plan, in other words. Now, the most efficient way of doing that is selected by the CBO, the cost-based optimizer, and it does so with the intention of reducing pressure on system resources. Now, information about the CBO and the decisions it makes and everything like that are monitored and tracked by the system monitor background process. Now, one of the tables where information is stored about this is in the call usage table. Now, in terms of actually getting something useful out of it, it's not like a smoking gun kind of thing, but it's just, it does provide useful evidence. But again, we don't get to see the complete SQL text here. We can infer. This table can be used to infer information about what selects have taken place. So if we dump, if we describe the call usage table, we can see that the first column is hash, which is the object ID of the table upon which a select has been issued. The int col is the column number that was selected and so on. And these predicates here are essentially a while, a where clause. So for example, this like preds here would indicate that someone has done a query like select password from DBA users where username like sys%sys, syn% quote kind of thing. Now, that would cause the CBO to add an entry for the DBA user's object ID and the column for the password, and the like predicate would get account number 1, and so on. And obviously the timestamp upon which this all took place at. Now, given that we may have been compromised, we can look at this call usage table, but with no frame of reference, we don't know whether there's anything untoward in there. Well, we can compare copies of the current call usage table to copies in our backups. Another way to do this is look for odd entries. For example, if we know we have no application in our company-wide web applications never request data from table X, but wait a minute, there's an odd entry for table X in this call usage table, then that might indicate foul play. So for example, let's say there's a, let me think of a suitable example. For example, DBA procedures. No one ever queries DBA procedures because we're in a production environment now, everything's ticking over, it's been ticking over for the past 2 years, and no one should ever select from that table because we don't need to modify the procedures anymore. But suddenly we find an entry in our call usage table where someone's been analyzing procedures that are in our web application. Let's say we've got a web application that's using the Oracle PL SQL gateway, and they're broken in, they're trying to ascertain information about our PL SQL application on the back end. They might query DBA procedures, or they might query, for example, argument $. So if we find entries for this in there, and we know none of our applications request from there, or none of our users are supposed to request from there, or there's no database job or anything like that doing it, then it should be cause for concern and a reason for investigation. So what we would do, obviously, is marry those object IDs in the column number 1, with the object name in obj$. And if something stands out, by the way, whenever you're doing a forensic analysis of a compromised database server, you should always do it in the presence of the DBA, because the DBA will know instantly when something's wrong with his system or something is untoward. For example, if you, as a database forensic examiner, looked at the users table, and you would look through the users and see, Jim, Jane, John, whatever kind of thing, you're not going to know whether they're valid users or not, but the DBA is going to instantly recognize that Jane, there's no Jane who works for us. So you should always do it in the presence. If you're not, of course, the DBA doing it yourself, you should do an evaluation, forensic examination rather, in the presence of the DBA, because they should instantly spot if they're worth their weight anyway. So here's an example. By the way, the reason we do the auto session and set the time format to this is because otherwise we would just get 31st of July 07, which isn't really that. when we require decent timestamps, we need it down at least to the second. So we can see when all these took place. There's an object 21. Don't know what was that a question? Sorry. There's a table with an object div 21 that has been queried at some point, and we can see there's an equality pred down here. Like preds, no one actually used a query on that, but you get to see what's going on. So anything in here that shouldn't be in there should be caught.